Hello, my DevNation friends. Thank you very much for coming because today have like a super exciting talk about some of my favorite subjects. We're going to be talking about Quarkus. We're going to be talking about Reactive. We're going to be talking about RESTEasy. And today's presenter is a super engineer from Red Hat. He's working with Quarkus and he's streaming directly from France. So I would like to welcome Stephane Epardaud to the stage. Welcome, Stephane. So, how
Hi.
is the weather in Nice?
Surprisingly, it's raining today.
Oh, it's a pity, but well, you're not missing much because it's much better if you're watching us live because we're going to have an amazing talk. So, without any further delay, I'd like to say that, live from Cairn, North Carolina and Nice, France, welcome to another Tech Talk.
Great. Thanks a lot. So today we're going to be talking about RESTEasy Reactive and why should I care? I mean, what is this about? Why should I be concerned about this? My name is Stephane Epardaud. I work for Red Hat. And what we're going to do today is give you a brief glimpse as to why you should care about async, reactive, blocking, and all those terms such as the event loop, IO thread, worker threads, all those terms that hipsters and C programmers already know, trying to explain them, and how you can then turn your classic REST endpoints from old style to super fast and really cool. And we're going to do this not just by talking, but by doing a live demo. Most of this talk, don't worry, is not going to be those slides. It's going to be demos. And in the end, we'll recapitulate what we've shown and get some questions. So first question that we're going to answer is, why should we care about reactive programming and RESTEasy Reactive? So in order to give you an idea of why you should care, let's see what a traditional architecture of a web server would do, and explain what IO and worker threads are. So traditionally, you would get, when the user makes an HTTP request to your REST server, so you're going to have the Quarkus server answer that HTTP request. And Quarkus is using Netty underneath and Vertex, which are super fast HTTP pieces for dealing with the server bits of HTTP. And they are asynchronous and reactive. And the way it works is that they schedule everything on a single thread. Well, it could be actually more than one thread. Traditionally, we can have one thread per core. But really a low number of threads that deal with IO and dispatches all the IO requests. Now, traditionally, when you use RESTEasy, Classic, or really all the old-style web frameworks, when they get some I/O and a request, they dispatch those requests to worker threads. So what's a worker thread? It's a pool of threads because creating threads is expensive, and we don't want to have too many on a server. So we have a pool of threads where we can just get one thread and send him a task, and then wait until the task is done. So for instance, when you have an endpoint that is going to serve an HTTP request, you grab a worker thread, give him the task, and you're going to do the task on the worker thread. And if that worker thread is going to call the database, then it's going to start a connection to the database and then wait for the connection to answer. Similarly, if you are writing microservices, then there's a good chance that your endpoint is going to do an HTTP call to a remote microservice and then wait for the answer. So what is it that they really do when they wait? Well, nothing. They do nothing. They just wait for the database and the remote microservice. So who exactly does the work? Well, those services, the database, the remote microservice, they actually really use the worker threads, and they are CPU bound, we hope, while our worker threads sit around, do nothing, but they block all those worker threads. So the problem is that the more requests you have, the more worker threads you have that are blocked, waiting and doing I/O and just waiting and doing nothing while you're not using your resources adequately. So what happens in the end is that, well, the database does all the work, the worker threads do nothing, and the user just, gives up. With async I/O and reactive programming, what we're going to do is cut each request, each endpoint action into smaller pieces that can be done independently of I/O. So for instance, if we get an HTTP call, what we're going to do is that we're going to trigger a database request directly on the I/O thread, and then that sends the request to the database, and then we're done. We terminate. We stop the endpoint processing. We return to the I/O thread, and we do something else. And at some point later, the database is going to answer. It's going to talk directly to the I/O thread and say, look, I got the answer from the database. You do what you want with it. And the I/O thread is going to schedule the rest of the endpoint, the rest of the request, and process the database response. And it can do that on the I/O thread directly, because none of this is blocking, none of this is going to be locking up the I/O thread and waiting forever. Similarly, if you have a remote microservice, you're going to trigger the HTTP call and then relinquish control to the I/O thread, and then schedule later the processing of the HTTP response when it gets there. This way, we can free worker threads for tasks that are really CPU bound and really need a worker, and the I/O thread is free to process requests really fast. So as you can see, this is nothing new. This is just a way to pipeline all the requests into something that keeps moving forward and is very efficient and never stops. So let's get to the point of what really is RESTEasy Reactive. RESTEasy Reactive is a JAX-RS implementation, but we done from scratch, both the client and the server bits, and from scratch with requirements tailor-made for Quarkus. So the first thing is that it's really asynchronous by default to get really great performance. It's Quarkus. It's specific to Quarkus, but it's also specific to Vertex. It has reactive support with Mutiny, which is a great reactive application that we're using in Quarkus all over the place to simplify all the reactive programming. I'll show you bits of it later. It has a super fast architecture. To give you some examples of what we're doing is that we're completely getting rid of reflection at runtime. And to do that, we generate a lot of bytecode at build time that is going to be responsible for handling all those requests and all the endpoints that you have. We do pipelining of the endpoints. To give you an example of what I mean by this, traditionally in JAX-RS, you're going to be deserializing the body of the HTTP request at some point before you hand it over to the endpoint itself. You're also possibly going to invoke some filters and interceptors, and then you invoke the endpoint, and then you're going to look at the response of the endpoint, possibly invoke more filters, interceptors, and possibly marshal and serialize the answer back to the client. So all these are cut into chunks and pieces of small steps that we put into a pipeline, and each of those steps can be independently suspended and resumed later when I/O becomes available, etc. So it becomes really easy to cut the execution into small pieces, and also eliminate dead steps. Traditionally, you would go through the whole request of JAX-RS and see, okay, now let's do filters, now let's do deserialization, now let's do the endpoint. Here, because we generate everything at build time, we know if an endpoint has any filters, if it has anything to do, and sometimes it doesn't have to do serialization, deserialization, filters, and so invoking the endpoint is like super, super fast. We don't ask any questions about this at runtime. Everything is decided at build time. But it's not just about speed. We also have better APIs and new APIs. Well, I'll show you some of them during the demo. We also have better defaults, so we try to help you write the code more fluently and more succinctly. We have a much smaller memory footprint, and we also have great Dev UI support, which I'll show you in the demo. And where it really shines is that in addition to being just a JAX-RS implementation, it's also great in conjunction with stuff like Mutiny, the Vertex Reactive SQL clients, and Hibernate Reactive, all of which I'll be showing during the demo. So this is where usually, you start saying, okay, I get it, I want it. But the question we're also going to answer during this demo is it really hard? Because I've heard, turning everything reactive could be hard. No, this is not rocket science. We're going to be showing you that it's really easy. So I'll cut to my demo here. I have this project. It's a project that has a REST API. It's going to be using, we're going to start with the blocking version of the project to explain. So it's going to be using Hibernate ORM with Panache, which we'll show in a minute. It's going to be connecting to Postgres using JDBC, and then it's using the RESTeasy, traditional RESTeasy that everybody knows, with Jackson, because we're going to be doing some JSON with some Mutiny interrupt. And we're going to be showing the REST client as well. So this is the REST client. That's all the modules that we need. If I go in my terminal and I start Quarkus, then I'm going to be showing you what this application does. And I'm getting the application here. If I open my application, I have here the dev UI. And what I can show you here is the dev UI is something relatively new in Quarkus, where we have a sort of a web console where we show all the extensions that are available, and you can click to get directly to the guides, and you have some interactive pages that the extensions can provide to show you a bunch of stuff. Like here, I have the Open API extension. It gives me a link directly to the Swagger UI page where I can start listing all the endpoints that I have and calling them. So here I have a hello endpoint, for instance. I can try it out, execute it, and I get a hello. Let's see how this is implemented. It's implemented here. This is my JAX-RS endpoint. I have the hello endpoint here. It's just traditional JAX-RS. I'm returning a string. It's the explain. It's a get method. The path is hello, and I'm returning something that points to the URI behind which we're running. And so I need to inject it with that context URI info. And when I call it, I say I get a hello RESTeasy from this URI. Okay, so this is easy. What else do we have? We have an endpoint that gives me a list of fruits. Straight out. Oh, okay. I have two fruits here. Let's see how this works. I have here my endpoint for fruits. It's a JSON endpoint. It returns a list of fruits. I have an optional parameter where I can query by color. I can filter fruits by color. But by default, I'm going to be listing all the fruits. So what is this thing? Oh, this is my entity. This is where we're using ORM with Panache. So the ORM with Panache is a layer on top of traditional Hibernate, where we extend a certain class called the Panache entity, and then we don't need to generate the getters and setters. Every public field has them generated for us. And we can just concentrate on writing logic methods here, like such as find by color, which delegates to superclass methods that do a lot of stuff for free. So here we're listing all the fruits with a criteria, with a predicate here, where we want the color property to be of this value. This is simplified HQL. You can even include real HQL. And we have, so list all is provided for free, and we just implemented the find by color one. Let's try it out. We can filter here and just get the yellow ones. You can see we got the banana. We have another endpoint which allows us to get fruits by ID. So again, let's try it out. Fruit number one, all right. And what happens if I try an ID that doesn't exist? Oh, I get an exception not found with a JSON error body. That's good. That's cool. So here, this is the endpoint. I'm getting an ID from the path, that's fine, and I'm trying find by ID. Again, a method provided for free. and if I don't find it, I throw an exception. All right, so but how does this exception get turned into the error? This is done with an exception mapper here. It gets turned into the JSON error that is provided here. Okay, that's fine. What else do we have now in our endpoints? We have the list of fruits. We have hello. We have a stream as well. This one is interesting. Let's try it out. Let me show you. This is SSE. So SSE is server sent events. Here I'm starting a server sent event. Let's see how it's implemented. It's here. It's a stream. It produces a server sent events. Traditionally in JAX-RS, you would have to mess about with injecting SSE types and doing things that are really complicated. But here with Mutiny integration, we can just say, I'm going to return a multi of fruit, which is something that can return a number of instances of fruit as the time goes on. We have a special kind of Mutiny value, a multi-value that is a broadcaster, which we can use to return the SSE value, and then the RESTEasy will subscribe to this, and every time something becomes available on the broadcaster, it's going to send it to the SSE clients. And here, when we add the new fruit, we're going to persist the fruit, again, the method provided by Panache, and we're going to tell the broadcaster, hey, we got a new fruit, so return it. So now let's try it out here. Let's add a new fruit. I'm going to add a fruit that is blue, blueberry. And if I execute it, I should have one that appears here. I got an element on my SSE stream, and if I add more, then you can see they keep appearing. All right, so we can do SSE. That's cool. What else can we do? Well, there's another use case that happens pretty often when you're doing endpoints. And this is the case of having to call HTTP services. And in this case, I'm going to show you what happens when you try to do a lot of calls. Like, say, I have an endpoint that needs to talk to a number of devices, remote devices, or web services that it needs to coordinate and whatever. So here I'm going to assume I need to do 1,000 calls to 1,000 different machines, and each call takes 1 second to do. So I don't have any 1,000 machines running here, so I'm going to fake it and invoke it on myself. So I'm going to do the remote calls. I'm going through the client, HTTP client, but they're going to be located right here. And I'm going to fake it by sleeping for a second before returning a number. So what I do here is that rather than do 1,000 calls one by one, which would take obviously 1,000 times 1 second, which is too long for this demo, I'm going to be using the RX API of the JAX-RS client, which allows me to asynchronously, in theory, send all those calls. They're going to be fanned out to the 1,000 clients, and then wait for them all to be done, and then return the answer. So let's see what happens if I actually do this. I'm going to open the web console to show you the time it takes. I'm going to throw the fan out. If we go to the terminal, we can see that they're executing, and they're taking a while, right? And I know exactly how long they're going to take because I've done this before. They're going to take about 20 seconds to answer. You see? All right, about 20 seconds. I got the answer. So why is this taking so long? Well, there's 2 reasons here that I know of. This is going to be blocking the worker pools because we're doing work. Let's pretend we're actually doing work and that it's CPU bound, but it's the same thing. We're locking up worker threads. And here, the client used underneath by the implementation is actually also going to block worker threads because it's not really asynchronous. So it's not ideal. And we think we could do a lot better. So let's go and try it. We're going to turn this into using RESTEasy Reactive. How do we do this? Well, it's just a matter of using the right extensions. We are going to be using RESTEasy Reactive, RESTEasy Reactive with Jackson. We don't need this one because it's already integrated. We don't need this client, but we have one here, which is the JaxRS client reactive. And I'm just going to import those things and see if it runs. Well, I can notice here already I have one problem, which is that the SSE element type annotation that we use to describe what each type of the server-sent event is going to be serialized as, this doesn't exist. All right, fair enough. Let's just suppress it, remove it. We don't need it anyway. And that's it. Oh, hold on. Really? Well, let's see if it works. Let's try our application. Let's see if we still have something here. We still have something here. So let's see if we still have a hello. Try it out. Yes, we still have a hello. Let's see if we still have fruits. Oh, we have a problem. What do we have? We have attempted to perform a blocking operation on an IO thread. This is not allowed, as blocking the IO thread will cause major performance issues with your application. If you want to perform blocking entity manager operations, make sure you are doing it from a worker thread. Why is this? Well, here, the value proposition and the default from RESTEasy Reactive is to say, we're going to run by default everything on the IO thread, because this is what makes your endpoints fast. And then we detect if you start blocking on the IO thread. And so here, by calling RESTEasy, which is using JDBC underneath, it's a blocking API, we're actually doing IO. And so we're detecting this and telling you, look, you can't do this. So one way to deal with this is to add the blocking operation, the blocking annotation on your endpoint, and try this again. Try this again. And this time it works. All right, so why does it work? Because RESTEasy Reactive will then see this annotation and say, oh, this endpoint actually needs to be invoked on a worker thread. But this is a bit of a clutch. This is not ideal, right? What we want is for RESTEasy to actually work on the worker threads, on the IO thread. And so we're going to stop using a Hibernate ORM, and we're going to turn this into Hibernate Reactive with Panache, which is the reactive version of Hibernate. And we need for this a different sort of driver, which is the reactive Postgres client. Now, this produces a number of errors, but I also need to change the configuration to make it use not JDBC, but the reactive driver. That's the only thing we need to do. And then let's take a look at what we need to fix. All right, this is not ORM anymore, but we have a different sort of Panache entity. It's just in a different package. All right. Now we have this find by color thing, and the type returned by list is actually not a list anymore. It's a uni of a list, because this is reactive. We're not returning the element itself. We're returning a uni, which is sort of like a promise or a completion stage, but with much easier and friendlier methods. So we're returning something that can give us a uni later on when we listen to it. Let's take a look at our greeting resource. So we need to make a few adaptations here as well. We need to turn this into something that returns a uni. And here for find by ID, we also need to adjust it a little bit. It's still going to return a uni, but we're going to return, and here I have to fight a bit the Java type system, but don't pay too much attention to this bit. We're going to do something when we get an item. If it's null, we're going to fail with this exception. So we return find by ID, and then if it's null, we fail with this exception. So this is the sort of pipelining that I described earlier that we're doing. Here we're really returning actually two operations to the IO thread that invoked us. We're returning the first operation, find it by ID, and keep doing your thing, IO thread, keep scheduling other stuff. And when you get the answer, then we get an item, and then we do the second step of the operation, which is that if it's nil, we're going to throw an exception. All right. So for adding fruits, it's again a matter of turning this into a uni, and we get rid of the transactional because we actually need to do this using the API. So panache with transaction. What are we going to do? We're going to persist, and then we're going to do other stuff like invoke our callback. We're going to say, when you're ready, we want to do on next. And then we're going to map the return value, which is really void at the moment, it's not very useful, into a fruit to make sure that we return a fruit. So we're going to run the persist operation in a transaction, and then when it's done, we're going to broadcast that we have something, and then map a value of void that doesn't do anything into the fruit that we want to return. And for SSE, we don't need to do anything. Let's give this a spin. Go back here and try the list of fruit again. We have no fruits. Oh, we have no fruits. Obviously, I messed up here because at startup, I was deleting all the fruits and inserting 2 fruits. But this is reactive now, so we need to do something else. We need to say, again, run it in a transaction. The work is going to be delete everything, and then going to flat map it. This is a reactive operation which takes the previous operation and drops the value and returns and turns it into a new operation. And the new operation, I'm going to ignore the result from the previous operation. I'm going to turn it into an operation that persists the new fruit. And then I'm going to turn it again into persisting the new fruit, second fruit. And what do I do with this? I am going to await indefinitely for it to be executed. And that's it. So now I'm going to try it out again. Get back to getting the list of fruits. And now I do have my fruits injected, and I do have my endpoint, and it runs on the IO thread. You can see I didn't have to make too many changes. And also, well, notice that I haven't restarted my application once. I haven't gone to, everything happens really fast. It's the dev mode, it restarts everything. So everything still works, but can I make this better? Well, yes, I can also, I told you, this is not just about performance. We have also better defaults. So for instance, here we can get rid of all those produces types that are not useful because we can infer it from what we see as the result type. Here we're returning a string, so it's text plain, returning something that can be generated with JSON. So there we go. Here we can simplify it further with getting rid of query parameter and turning this into a REST query. There are lots of simplifications we can do. I can also show you how fast we can turn this call by making sure that we're setting the right settings for going to the invoking as many calls as we can to the client. Here we turn this into a uni of integer to not block the IO thread, and we're going to return a uni, create from item counter, and then on item I'm going to simulate a delay by duration of milliseconds. There we go. So I'm just going to turn this into a reactive endpoint, not block the IO thread. Let's see now how long this takes if I call this. Well, the first time is going to restart Quarkus, so it's going to be a bit longer. So it's 1 second to restart Quarkus. It takes 2 seconds now to fan out 1,000 requests to services that take 1 second each. So you can see it's really much faster, and we're not wasting time. I think I've gone really slow with this demo, so I'm going to go back to the slides. And so what have we learned here? If you want to start using RESTEasy Reactive, just start importing RESTEasy Reactive instead of RESTEasy. It's non-blocking by default for speed, but we can also support blocking use cases, so you can use the ad blocking annotation if you need to. It's faster by default, but if you don't need more speed, you can use the usability improvement and simplification, getting rid of lots of stuff that you don't need. It's available now. We're looking for feedback, so don't hesitate to try it and give us feedback. And that's all I have. So if you have any questions now, we can take them.
Yes, we do have some questions. So let me try to find them here. So first one, Sebi is asking, will RESTEasy Reactive become the default like when you're generating the project and maybe just rename to RESTEasy?
We're not at this stage yet. We don't know if it will become the default. I think there's probably value in supporting both. I mean, RESTEasy. There's really fundamental differences between the two approaches. If you want speed, definitely go with RESTEasy Reactive. If you want experience and maturity, and lots of extensions that have been added over the years, then you can stick with RESTEasy Classic because it really has a lot of extensions that we're probably not going to add to RESTEasy Reactive. To give you an example, at the moment we don't really support XML in the RESTEasy Reactive, so we're very focused on JSON. So you know there's still good points for both. So we don't have any plans yet for getting rid of one or the other.
Yeah, not sure a lot of people will miss XML in REST endpoints, but yeah.
No, but I mean, it's not the only thing that it does that RESTEasy Reactive doesn't do. They shine on different aspects, so there's value in both.
Good. And Antonio Gonçalves is asking here that in your code you return a uni of a list of a fruit. Why not just a multi of a fruit?
Because, well, that's a good question. So the difference between the two is that a uni is something that is a one-shot operation. So it gives you a list directly in one go, whereas a multi is something that can come over time. And so traditionally, if you want to return a bunch of elements in one go, you return a uni of a list. If you want to stream them, like with SSE, as I showed, then I would use a multi. The other thing is that when you're querying the database, databases are not really made for streaming data. They actually give you a bunch of results in one go. And so you can pretend that they're streaming those results, but they're really not. They're giving you a chunk of results. Like you ask for 10 results, they give you 10 results. They don't stream the 10 results. So we could fake it, but there's no real value in that. So we're really showing you. And also, if you fake it, then people start getting confused as to whether this is streaming or this is not streaming, and do I still have a transaction, etc. How long does it stay open? So really, Hibernate Reactive went for lists, uni of list, and I think that makes a lot of sense.
Okay, and Antonio has another question. So add transaction does not work with Hibernate Reactive, right?
Right, which is why I turned those annotations into calls to the API panache with transaction. We're looking into integrating it with the annotation, but there are a number of things that need to happen before, and we have discussions about this. But the main point is that the reactive drivers will commit and roll back the transactions in a non-blocking way, but the whole JTA stuff and infrastructure that deals with interceptors and transaction manager, etc., is not made for reactive programming, so it doesn't really handle asynchronous commits and rollbacks. So there's quite a lot of R&D and experimenting to be done before we can actually support this. At the moment, you have to use the API, but it's not. I showed you it's not very intrusive, right? It's hardly more characters than the annotation.
And Raphael is asking, will this approach work with non-reactive JDBC drivers also?
Yes, you can. As I showed you, you can just get around it by scheduling your endpoint on a worker thread using ad blocking on the endpoint. You can also add ad blocking on your class to make all the endpoints work on the IO thread. And you can also put ad blocking on an application class, which means that the whole application will invoke every endpoint on the worker thread.
And the last one, Angel Carmona is asking, I haven't understood very well the fan out function. Can you explain
Yes,
that again?
so the fan out function, I can probably show it again. The work we're doing is that we're sending 1,000 HTTP requests to supposedly we pretend that it's 1,000 different hosts. So the theory is that we can send 1,000 requests, and they do all the work. They each take 1,000 to answer. They each take 1 second to answer. So in theory, I send the calls. I wait for each one of them to answer. They take 1 second, and then I'm done in 1 second because I sent everything in parallel, right? So we're using the RX version of the client API from JAX-RS, which allows us to send 1,000 calls and then wait for them all to be done, hopefully in 1 second. Obviously, in the case that the client is blocking and the server is exhausted by running out of worker threads, it's going to take 20 seconds, as we've shown. And when we turn to using the proper RESTeasy Reactive client, which uses the HTTP client of Vertex underneath, and we're not exhausting worker threads, we are able to send 1,000 HTTP requests in 2 seconds. And I think we're only paying the overhead because it's running on the same machine. But if you were fanning them out to 1,000 hosts on your local network, it would go faster. Does this help? I hope.
Yeah, I think so. Yeah, we're already on top of the hour. So I would like to thank you, Stephane, for this amazing content and amazing presentation.
Well, thank you a lot for having me. Glad to have done this.
Awesome. Yeah, we hope to see you soon with other talks and other content. And for you, thank you for watching today's DevNation Tech Talk. I hope to see you soon in another DevNation offering. Yeah. Stay safe.
Bye.